Okay, Bismillahirrahmanirrahim. Let us compare question number 2. Solve the initial value problem because the initial conditions are given. Okay, so solve this differential equation. It's a linear differential equations, and we are to use method of integrating factor because definitely we cannot separate the variables. Alright, so let us compare the solution. So this is the question just now. Okay, in order to, first we are to compare to the standard format of this differential equation so that we can recognize the P and calculate the integrating factor. That is the formula. Alright, so what is P? Compare here. As we can see there, we cannot compare yet, right? Because there's an X there. So we have to divide all with X, so and then rearranging it in this form. Okay. And then hence as we divide by X, we get dy dx. And here we bring it on the other side. Okay, minus y. Divide by X again, we have 1 on X of y. And on the right side, divide by X, we get a remaining of X cosine. So only after that, then only you are able to recognize your P. Okay, help me. What is the P there? Okay, compare. So the P is attached to the Y. Here we have, we see the standard equation is in the form of dy dx. So it's supposed to be dy dx, sorry. Okay, dy dx, right? And the P, and there it is in the form of plus P. So meaning our P there carry negative 1 on X. Okay, so you have to get the P and then into the formula of your integrating factor. Okay, so help me check my work. E power integrating, our P is negative 1 on X dx. The negative can be put outside. Another way to say, we are supposed to integrate 1 on X dx. So integrating 1 on X is actually ln X. So we get e power ln X. And because we like to use that property, if we have, like say, e power ln Y, it is Y. Okay, there cannot be a negative over there. So we need to bring this negative to the log function. We do know that whenever we have log X power B, okay, we can bring down the B log X, right? And vice versa. So let's bring this B so that it becomes ln X, so that now we can read it as e power ln of our Y, which is X power negative 1. Okay. So hence, as we simplify, the mu is negative 1. Right, so that is our first mark. Okay, it has to be correct, and sometimes there is a mark, okay, for the calculation that you are getting to get to your answer of your integrating factor. Next, after we have got the integrating factor, step number 2, multiply all with this integrating factor and combine the left hand side. So this dy dx, let's multiply it by this negative 1. Okay, so hence we get negative 1, right? Sorry, this is not negative 1. Check my work. It's supposed to be the Y. The Y is actually this X power negative 1, or it is 1 on X. That's the correct answer. Okay, this portion there, right? Not this one. Okay. Right. So we multiply this 1 on X with the equation. Check my work. So 1 on X, multiply this dy dx. Okay, let me write it down. So we multiply and we simplify, and multiply all and combine. And as you can see, this is the expansion from the derivative of 1 on X and Y. Okay, you can check if our U, let's say U is, or F is 1 on X, or meaning x power negative 1. This is just to check. F prime is negative x power negative 2 or negative 1 on x square. So correct here, this part, negative 1 on x square. And if our y is y, okay, or the g is y, so the g prime is dy dx. Okay, so according to the product rule, okay, I put it down here. If we have a derivative of f times g, the product rule formula is f g prime plus f prime g. Okay, then you can check such that f 1 on x, g prime is dy dx, plus f prime is negative 1 on x square. Okay, and g is the y. So that, okay, expanding that, this is actually the derivative of fg, or in our case is 1 on x and y. Nice, isn't it? Okay, as of the right hand side, we simplified when we got that one. So up to this level, there might be 2 marks. You have to multiply all with the mu and combine it. Okay, so this value, you have to show it, okay, A1 or S1. Okay, must be correct. Right. So you don't really need to show all this. This just to prove, okay, on the quotient, oh sorry, on the product rule that we've got. Okay, next, before we are to integrate, let's rearranging it. This partial fraction, okay, of dx, we multiply on the other side. So now it becomes cosine x of dx. Okay, after we have got that, then only we are to integrate both sides, and let's call it ds. The derivative of ds is s itself, s. Okay, so that the derivative of a function variable y on x, we call it, is the y over x itself. Okay, so integrating cosine, we get sine, positive, right? And let's put the constant of integral on the other side. So hence we get our y. Okay, multiply all with x. Okay, so there's an integration that you have to do. Make sure that you show it, okay, on how to solve for the integral, and then your answer, general answer, with a constant c. So this question given an initial value, okay, and a condition when it says when x is pi, then the y is 2 pi. Okay, so let's substitute the values there. So the y is 2 pi, check my work, and the x is pi. Okay, so and again sine pi. You all, what is sine pi? Okay, our basic mathematics, you have to know it. Sine pi is what? Sine pi is 0, right? Okay, so hence we can solve our constant c, which is, this is 0, so we have 2 pi being pi c. Okay, so hence c is 2, right? Okay, so don't stop there, make sure that you conclude your answer. So hence our y is x sine x, okay, plus 2. So that's the final answer. So how many marks do this question carry? It starts with finding the integrating factor. Okay, first we have to recognize what is the p. By rearranging it, we need to divide it by x first to be able to recognize the p. The p carry negative, yeah, as you compare to the standard equation, right? And then we calculate for the integrating factor and simplify. And then we are to multiply all the equation integrating factor here, the differential equation with this integrating factor, we multiply, right? and we combine it, okay, a1, and then we rearrange it first, dx, and integrate both sides and solve the integral, and then we substitute the values given, okay, with this initial value given, and solve the answer, the final say of our y. Okay, so that is the solution for our linear differential equation. This question carry 8 marks, right?